For more information, please visit SGMAK Associates website.
Hi, Hi. In this module, I'm going to present an example that shows how do you compare alternatives when you have unequal service lives. One of the major parameters in comparing alternatives is the useful service life. If they're equal, we're talking about two alternatives here. If they're equal, you can use net present value because they have an equal plan period, so you can convert all cash flows, both cost and benefit, to the present and select the one that has a higher net present value. What do you do when you have unequal service lives? The following example shows how to compare alternatives when useful lives or service lives are not equal. Two different approaches are presented, so we'll solve in two different ways. In the first method, a common plan period is considered. We pick up a common plan. Each alternative is replaced with an identical alternative, similar cost structure, identical cost structure, multiple times as required during the plan period. For example, if you're comparing alternatives with 4 years and 8 years of service life respectively, we take a common plan period of 8 years, which is the minimum that will cover both. We'll consider 8 years common plan period. During this plan period, first alternative is replaced with an identical alternative at the end of 4 years because this has a 4 years of service life. This approach equalizes the impact of unequal service lives. With this modification, net present value criteria can be used to compare the alternatives. So here is an example with numerical values. Alternative C has an initial cost of $5,000, useful life of 4 years, and generates a uniform annual benefit of $2,000, no salvage value, at the end of its useful life. The other alternative, alternative D, has an initial cost of $12,000, useful life of 8 years, and generates uniform annual benefit of $2,500, also has no salvage value. In this case, we use a plan period of 8 years and we replace the one that has a period of service life of 4 years, C, at the end of 4 years. The desired discount rate is 9%. The cash flow diagram, as you can see it next, for 8-year plan period, alternative C is being replaced with an identical alternative at the end of 4 years, and that repeats another cycle. So the net present value of C, if you take this cash flow and convert the net present value, we have all benefit, present value of all benefits, which is A times P over A, 9 and 8. A is the uniform annual benefit, minus the first cost for the first one, $5,000 now, minus a future cost of $5,000 at the end of 4 years. We have to convert it to the present value, which is 5,000 times P over F, converting future to present, interest at 9 and 4 years. And if you use the table lookup values, the number comes out to be $2,528. So the net present value of alternative C then is $2,528. Now let's look at cash flow diagram for alternative D. It's simple enough. It has initial investment of $12,000, annual benefit of $2,500, no salvage value, service life of 8 years. So that gives us net present value of D, present value of all benefits minus present value of all cost, and that comes out to be $1,837.05. So as you can find, comparing once we equalize the service life, and compare the net present value. Net present value of C is higher than net present value of D, so we'll prefer C. The useful lives are not, when they're not equal, we can solve based on another approach is you can solve based on equivalent uniform annual benefit, EUAB, minus equivalent uniform annual cost. In this case, in this approach, we don't have to equalize the service life because the common plan period, which is the integer multiple of each plan period, we don't have to do that. In this case, the assumption stays the same, that when you replace an alternative with this identical cost structure. Approach. If you look at alternative C, we look at the cash flow diagram, convert all the benefits in terms of a equivalent uniform annual benefits. So it happens to be $2,000. So that's the uniform annual benefit. Now, to find out the equivalent uniform annual cost, you got to take $5,000 at time t equals 0 and spread it over an annuity cost for 4 years. So that is 5,000 times A over P, 9% and 4 years. Use the capital recovery factor here. And that comes out to be $1,543.50. So on an annual basis for alternative C, we have a uniform benefit of $2,000 end of each year and uniform cost of $1,543.50 end of each year. So the difference is $456.50. That is the net earning, if you can think about, or net profit from this alternative end of each year. Let's look at alternative D. The plan period is 8 years, and we have a uniform annual benefit of $2,500 end of each year with initial cost of $12,000. So uniform annual benefit is $2,500. Equivalent uniform annual cost is $12,000 multiplied by the corresponding capital recovery factor, which comes out to be $2,168.70. So the net earning or net profit in this from this alternative is $331.60. Again, when you take a decision, you look at that C is more profitable, more desirable compared to D. So we'll prefer C over D. We had the same conclusion when you use the net present value after equalizing the service life.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.